Trips here. Let's talk about cooling. So I just posted up a blog post about how I'm using preemptive cooling at nighttime to cool my greenhouse during the day. How it works is I have 3 sources of cooling that are all centered around this central reservoir that I call my HVAC reservoir. The 3 methods are, one, I have air. If possible, I can air cool the water that's in the reservoir. And I have 2 pumps. You see 3 there, but the orange one's not connected. These 2 right here. This one's connected to the what I call the HVAC system, which are these pipes right here that go to various devices. They go to the CO2 generator, but they also go out. Right behind this wall, outside, is a chiller. The chiller is actually the second source of cooling for my greenhouse this year. It's a new addition I've talked about, I believe, last time. And then the third source is, of course, geothermal, which is controlled by this pump. So why did I start out showing these power supplies? Well, I actually have 4 power supplies here. This one's for lighting, but these 2 control the pumps individually. They're both hooked up to different controllable sockets on my MFI outlet, so I can turn them on and off individually. And then the third one is just for the fans. So the way my cooling at night works is, first I need to determine if I need to cool during the night. I don't want to, like, if it's going to rain tomorrow and it's going to be a high of, 17 C or, stay below 70 Fahrenheit, I don't need to cool during the nighttime. I can save that energy. So I need to know if tomorrow is going to be warm. I can look at the forecast tomorrow. That'll give me the temperature, but the temperature outside, what a typical weather forecast would give me, does not tell me much about the temperature inside. So how do I determine the temperature inside for tomorrow? I have a bunch of sensors that I've been collecting data on for almost a year. One of them is over here. This is my sensor for reading the indoor humidity and temperature. But how do I predict that? So what I thought up is I wanted to teach myself machine learning techniques using a software system called TensorFlow that was originally published by Google, and use the data from historic weather, use the data from my greenhouse, and kind of come up with a model where I could predict, train a model to predict tomorrow's indoor greenhouse temperature. So if it's outside and it's 17 degrees Fahrenheit, Celsius, but it's sunny, it's going to cook in here. It's going to get really hot. So I can't go by just the outside temperature alone from the forecast. I need to know really what it's going to be inside the greenhouse. So I got that hooked up, coded out, and added to my my software that controls the greenhouse. And I just kind of got it, I think, working last night. I really haven't tested it out. We'll see if it works tonight. So what it does is if it's nighttime, it checks to see if the temperature tomorrow via the weather forecast is going to be hotter than the set point in here. If it's hotter than the set point in here, I don't care. Like, I'm going to need to cool. I'm not going to be able to get the inside temperature of the greenhouse lower than the outside temperature. That's just not how my system works. So if the weather forecast tomorrow is above my set point that I like to keep it in here, then I pre-cool during the nighttime. I chill this reservoir as low as I can, potentially down to 4 Celsius or about 39 degrees Fahrenheit, and and I go with that. If the temperature tomorrow outside is going to be less than my set point, let's say it's 20 C, which is you know, in the 70s, then I want to check to see if it's going, what the weather atmospheric conditions are going to be tomorrow. If it's cloudy, or if it's going to be overcast, or partly cloudy, partly sunny, those kinds of weather conditions I have plugged into my model, so it can kind of give me a prediction of what the temperature is based on the outside temperature and based upon the atmospheric condition. I could plug in a whole bunch of different things. I could plug in barometric pressure, I could pump, you know, added humidity, but I'm getting decent results with just those two data sets, trained with my indoor temperature as the, I guess what they call it, the label in the neural network. So I'm within about 5 degrees, 4 or 5 degrees once we get really warm, and that's good enough. If so long as it predicts something over the set point, I know I need to chill. So how am I chilling? Well, to be efficient, I talked about how I'm controlling each thing individually. So the fan, I know the air temperature. If the air temperature is cooler than the reservoir temperature, which I'm reading from this sensor right here, if it's cooler, then I use the fan to cool. I keep these pumps, all the pumps are going, and the fan's going, until I get within about 1 degree of equilibrium with the air temperature. The reservoir equal the air temperature plus about 1 degree. Then I shut off the fan and I keep both pumps going. So I'm chilling it, but I'm not regulating the temperature, the air temperature of the greenhouse at all at that point. I'm assuming, so this is the geothermal pump, I'm assuming that the geothermal store is about 12 degrees Celsius, or somewhere in the 50s, mid 50s Fahrenheit. And then I monitor the reservoir temperature until it gets about 1 degree of equilibrium with that geothermal, what I think the geothermal temperature is going to be. And then I shut off the geothermal pump, and all I have is the chiller pump going. And the chiller pump will remove up to 400 watts of energy from the water until it gets to about 39 Fahrenheit or about 4 Celsius. Now, if my chiller, my reservoir, is able to achieve 4 Celsius, I can remove 7,200 watts of energy from the greenhouse throughout the day. That's 7,200 joules per second of energy. My greenhouse is only about 2.7 square meters. And using the solar constant, we know that solar radiation is coming in at about 1,000 watts per square meter. That's 2,700 watts of energy coming in. So I can remove 7,000, and I've only got 2,000 coming in. I should be able to maintain temperature if I can chill it that cool. And that's one, and it's very, very efficient to run the pumps during the night. It's cheap, and I can turn them off depending on how cool my water is. So I could go from about close to 400 watts with all three of these systems running, the fans and the pumps, to about just 50 watts when just the chiller's running. So that's really good. The chiller runs very efficiently at nighttime. Geothermal, of course, that's free energy I'm getting from the earth, and so far it's ended up working very well. Like I said, I just got these three on separate things today. I just got the software working last night, possibly, with the machine learning. Before that, for the past, I don't know, couple weeks, since about the 6th of June, I've been testing it with just the outside temperature, and I ran some the numbers from the data I'm getting, and I can already see about 1 degree Celsius difference, 1 degree Celsius cooler all around my mean delta, mean temperature difference between the outside and the inside temperature, is 1 degree cooler than it was for the previous month before I implemented even partially this system. So I'm hoping the machine learning will actually improve things even more. Now that I have these on dedicated power supplies, it should help even more, and hopefully I can get this reservoir just chilled as much as possible during the nighttime, so I can cool with it during the day, keep things nice and cool. So that is my update. 10 minutes of spewing just about everything I did on my blog, and I'll give you a nice glimpse of some nice tomatoes that we got growing. Everything is fantastic. My yield, it's only halfway through the month, is already better than last year this time. So we've got a few more weeks to go for June, and I'm expecting even more, maybe even triple, double or triple the output from last year. I've kind of figured some things out. I've kind of figured out what kind of tomatoes I need to grow. These are Paisanos. I figured out how to feed them. And we'll see that progress later. Some of these early fruits weren't fed the same thing as these later fruits, and I'm hoping the later fruit are even better than the new fruit, even though they are quite large looking. Just look at this amazing tomato. One thing that I've been noticing is I'm still getting these little runt fruits. You can see them up here, and I think that's just due to uneven pollination. Pollination hasn't been great, so I've been actually taking a vibrator lately and vibrating these. Some of these later ones I have tried to manually take a cotton swab and dip it in there, so we'll see. Where's my big cluster? Like this cluster, I do remember taking a large or a cotton swab and kind of swabbing the things, and same with these other plants over on this side. But tons of tomatoes, awesome yield. I've been making salsa. My wife's been using them. We've made some sauce with them so far. We're just loving it. All right, that's 12 minutes now. You got double the dose. You got a technical presentation on how to potentially use machine learning to cool your greenhouse. That's pretty advanced stuff. But even if you don't implement machine learning, just taking the forecast for tomorrow and then pre-cooling based on that, or even just pre-cool all the time. If you don't care about saving that energy, you could pre-cool during the nighttime anyway, just as much as you can. And maybe you'll use it, maybe you won't, but summertime you probably will. So there's a whole bunch of different ways to use this type of method, but the point is you can use it, you can take it where you want. You don't have to control maybe each thing individually. Maybe if you're happy getting it down just to 12C, what the geothermal is, you don't want to take it down. The chiller will try to cool lower than that, so you end up just trying to heat up, or anyway, you're using the geothermal store to heat up your reservoir from your chiller, so that's kind of inefficient. But you could do it. It wouldn't be that bad, but it wouldn't require any advanced technology. Just a simple, not even a timer. Just keep it running all the time, right? Cool it during the night, cool it all the time. All right, Trip Zero out.